This is question 2, and it says find out how your answer to question 1 part 2 compares with the frequency of infrared radiation. So you're going to have to do a bit of googling here, unless you already know the frequencies of infrared radiation. And I did a search on Wolfram Alpha and found out that the frequencies of infrared C are between these two numbers. So we're going to have to compare the answer that we got for our frequency. And our frequency was 9 times 10 to the power of 13 Hertz. And how does that compare with these frequencies? Well, we're going to have to convert it into gigahertz. And to do that, we're going to have to divide it by 10 to the power of 9. And that's going to give us 9 times 10 to the power of 4 gigahertz. And if we write this out with numbers, that's 9 with 4 zeros, that's 90,000 gigahertz. And that lies within this range, which means that it's part of infrared. Okay, so how does this explain why methane is classified as a greenhouse gas? Well, if this is natural frequency of methane, then that means that when there's electromagnetic radiation within the infrared coming towards it, it's going to want to absorb it because it's the same frequency that it's already oscillating at. So there's going to be a resonance at this frequency, which means that it's going to absorb a lot of the radiation. And that's what greenhouse gases do. They absorb infrared radiation and then re-radiate it back in all directions. So that's why it's classified as a greenhouse gas.